Okay, so today we're going to talk about trigonometric functions and their derivatives. So by this point you should be pretty familiar with the chain rule, product rule, and quotient rule, and as well as the power rule. And a lot of times trig functions is kind of the thing on tests where kind of throws you for a little bit of a curveball, and people will sometimes have a tendency to freak out a little bit or do things incorrectly. So today we're going to kind of work on our definitions as well as maybe going through a few problems if we get a chance at the end. So we're going to define the derivative of sine x with respect to x. That's what this notation is. It's the derivative of sine x with respect to x. Sometimes we'll say dy dx, and that would be the derivative of y with respect to x. So instead of y, we're having the derivative of sine x here in these brackets. And that's going to be defined as cosine x. And if we look at the graph of sine x, and I'll do my best job to draw a decent sine wave, something like this, and we see that it's going up and it's coming back down, and it's oscillating, so it makes sense that the rate of change of this function would also have to oscillate back and forth. So it can be proved in more advanced mathematics that this is indeed the case. If you make it to calculus 1C or second semester calculus, you can actually prove some of these things using Taylor series, which is really cool. Anyway, we digress. So the derivative of sine x is going to be cosine x, and there's going to be some relationship where if we take the derivative of cosine x with respect to x, that's actually going to give us a negative sine x. And you can kind of play with pushing a graph over and mess around with these things to make it kind of intuitive to you, and I do suggest that. But for now, just kind of rote memorization will probably do very well without thinking about it too much on tests. I know I've had some students in the past where they like, well, I can think my way through it if I have a few minutes just to kind of relate the functions to one another, and that's not really time that you want to be taking on a test to kind of derive these things. You want to have these be pretty automatic and be able to do the problems at hand. Anyway, if we took the first example here and we just put a negative out front of each of them, so see, we could either pull the negative out front here, or we could put the negative in there with the sine x. That would give us negative cosine x, so the derivative of negative sine x would be negative cosine x, and the derivative of negative cosine x would be giving us positive sine x. So it kind of goes in the circle where we can keep differentiating, and we'll get back to where we started off in the first place. Okay, so these are going to be some really good examples for us to get kind of used to finding the derivatives of functions with trigonometric components. Usually that on its own isn't the hard part. It's when we have to do something using these definitions in the context of another problem. So let's try and see if we can come up with a good one here. Let's see. Let's say we had some, z was equal to, let's see, cosine of 4 theta. It's good to get used to using other variables. Some of the times they will come up on tests, and in my younger days I would always put things in terms of like x and y, and occasionally on a test I would forget to put it back and I would get a few points knocked off on occasion. So it's good to get used to using different variables. Here we used a z, and we have a theta in here, so this is going to be like what you're probably used to having your x be, and this is probably going to be what you're used to having your y be, and this will be your independent variable, and this will be your dependent variable. Z is going to be dependent on this theta. Alright, So if we use our definitions up here, we knew that, well, we have it written negative cosine x is going to be equal to positive sine x. So if we multiply each side by -1, we know that cosine x, the derivative with respect to x, will be equal to negative sine x. So if we took d z d theta, that would give us negative sine x. Sorry, there we go. I was about to say x in there instead of a theta, so you have to be careful. Sine of 4 theta, and we're almost done, but this problem had a chain rule component of the 4 in front of the theta here, and that theta looks pretty terrible. There we go. 4 theta multiplied by the derivative of what's inside, and the derivative of what's inside is going to be that 4 in front of the theta. So the end result is going to be giving us negative 4 sine of 4 theta, and that will be equal to our d z d theta. Trying to see if we can squeeze another one in here on this page. Let's say we're doing on our spacing. Looks good. Okay, so let's see what would be a good one here. Well, let's see, this one will probably a nice one to cover. Let's see if we had it where we had some function f of x, and that's going to be equal to x squared cosine x. So this shouldn't be too bad. This is going to require the power rule for this x squared term. We're also going to need to use the product rule to be able to multiply the first and the second and their derivative. So let's get going. So let's use f prime is therefore going to be equal to, so different notation here. We took the dz d theta. We have the function in this one. We're just going to use the notation that f prime of x is the derivative of f of x. And anyway, here we go. It's good to get used to using all the different kinds of derivative notation. There wasn't one person who came up with one set of notations. A handful of mathematicians in the early years of calculus all kind of come up with little ways of doing things, and they each have their own benefits, which is why they're still used today. Anyway, so we have the first, and that's going to be our x squared term. So we're going to be using the product rule, so we need to take the derivative of the first, which is going to be 2x, times the second, which is our cosine x, plus the first, which is going to be x squared, times the derivative of the second, which is going to be, we had gone through some of those things up here, and that's going to give us a negative sine x. Alright, so let's see if we can clean that up a little bit. We have 2x cosine x minus, I'm pulling out the negative here, x squared sine x, and that's our answer for f prime. Okay, if you have any questions, feel free to post them in the comment section below, and as always, thanks for watching.